Hi, my name is Agill, and I'm here to teach you about stoichiometry, which is basically how we measure substances before and after the reaction has occurred. First, I want to talk about the mole. It's a unit used in chemistry, and it can vary based on what you're measuring. 1 mole consists of 6.022 times 10 to the 23rd of what you're measuring. We would call this number Avogadro's number. Examples of using the mole includes, if you want 1 mole of bottles, it would be 6.022 times 10 to the 23rd bottles. If you want 1 mole of an atom or an element, such as aluminum, it will be 6.022 times 10 to the 23rd aluminum atoms. If you want 1 mole of a compound, such as carbon dioxide, it will be 6.022 times 10 to the 23rd carbon dioxide molecules. If you want 1 mole of a polyatomic ion, such as nitrate, it will be 6.022 times 10 to the 23rd nitrate atoms. The molar mass is the mass of only a single mole of a substance. By using the periodic table, we can find the molar mass of an atom, compound, or a polyatomic ion. By using the average atomic mass given within the periodic table, you can multiply that number by the substrate of the element and add it with any other elements within the compound for a polyatomic ion. For example, in carbon dioxide there is only 1 carbon, so we multiply its atomic mass by 1. But in oxygen, there's a subscript of 2, meaning we'll multiply oxygen's atomic mass of 16 by 2, which then gives us 32. Next, we add 32 of carbon's atomic mass of 12.01 to give us a molar mass of carbon dioxide, which turned out to be 44.01 grams per mole. The mole highway is very useful when doing stoichiometry. It basically tells you how to get from point A to point B. Let's say that you're given a specific amount of grams and are asked to find the amount of grams that came from the product of the reaction. The first thing you would want to do is balance the chemical equation if one is provided for you. Next, you multiply the amount of grams given by the coefficients of the balance equation, and then you would multiply that number by the molar mass of the product. You would then divide by the molar mass of the reactant, and then you would get your answer. Now let's try a practice problem. How many moles of mercury 2 oxide, or HGO, are needed to produce 125 grams of oxygen, O2? The first thing we want to do is balance the equation. Because of the subscript of 2 next to the oxygen, we have to put the coefficient of 2 next to mercury oxide, which then makes us place the coefficient of 2 next to mercury. Now we find the molar mass of the oxygen. Remember, because of the subscript, we have to multiply the number given in the periodic table by 2, which gives us 32 grams per mole of oxygen. Now we can start calculating. First, we need to multiply the 125 grams of oxygen by the number of moles in mercury 2 oxide, which is 2. We know that because of the coefficient in front of it in the balanced equation. We then divide by the molar mass of oxygen, which was 32, and our answer would be 7.81 moles of mercury 2 oxide. Thanks for watching my video, and I hope that was helpful.